All right, so today we're going to finish up law of sines. Okay, same section. It's 4.2, part 2. Okay, so just as a reminder what the law of sines is for anybody who was absent yesterday. Okay, we went through and proved the first two parts of the law, sine of alpha over A, sine of beta over B. And the last part is sine of gamma over C. We're never using all three parts of the law at once. You're only using two at a time to make a proportion. So either the first two parts, the last two parts, or the first part and the last part. Okay, what I want to look at first is how you could have a triangle with two sides the same and an angle the same and draw two different triangles. Okay, so let's look at an example. So here's a triangle. Okay, what I'm going to do is construct another triangle. I'm going to keep two of those sides exactly the same length. I'll keep one of the angles the same and show you how I can make a different triangle. First thing I'll do is copy that segment. Okay. Does everyone agree that the segment I just copied and the one up above I just clicked on are the same length? I just copied it. Okay. So what I'll do is I'll just mark the way we would in geometry. Okay, next thing I'm going to do is I'm going to take that segment, I'm going to copy it, but I'm going to do one other thing to it. I'm going to flip it. Now, does flipping it change the length of it? No, it's just a mirror image of it. Okay, but it's still the same length. So this side is the same as that side. Now, the third side in the triangle, what I'm going to do is make that angle the same as the angle I'm about to create by drawing the line horizontal. Okay. All right. And if you're not sure, you could actually just drag the triangle up and see that the angle is exactly the same. So I just created another triangle. Okay. Two sides the same, one angle the same, but they're different triangles. So that's visually how you can get two solutions. All right. So what would be different here? Let's call this side A. Okay, and then A2, A1 and A2. Those would be different lengths. Sides B and C would be the same in each triangle. Okay, what angles would be different? We could call this one alpha 1. That one would be different, alpha 2. And the third angle here we could call beta 1 and beta 2. All right. And you know what I'll try to do? I'll stick with, I'll put all the 2's in one triangle, alpha 2, beta 2, A2. And I'll put all the 1's in the other one. Alpha 1, beta 1, A1. So there's two different triangles that have a side-side angle in common. This is the only case you have to check for that, side-side angle. Any other case, whether it's what we learned yesterday or what we're going to learn tomorrow, always has one answer. Always. Any question on that? Okay, and the no solution case, I'll draw one of those when we get to it, but that one's pretty simple. It's basically a triangle where all the sides don't connect because they're not long enough. Okay, so we'll look at that in a little bit. All right, let's try to solve this one. Okay, first thing we should do is make a sketch. Okay, let's figure out, is this even the type of triangle where we have to worry about the second answer? Well, looking at the table, the way you can tell that is if you've got one row with everything in it and you have one row with nothing in it. That is the side-side angle case. Okay? If you're not sure, though, you can make a sketch. If we put A over there, alpha would go right there. And we could put B at the bottom, which would put beta up at the top. So we have a side angle. So we do need to check for more than one answer. Okay, whenever you have side-side angle, you have to solve for something first. Okay. What do we have to find first here?
B, or beta.
Beta. Yep. You can't get C, you can't get gamma. Those will come later on. You got to do beta first. So we're going to use row B. And what other row do we have to use?
A.
Yep, we're going to use row A. So let's set up our proportion. Okay, we're going to solve for beta. Okay, Zach, what could I put on the left-hand side?
Sine of 35 degrees.
Okay, anything else?
6 underneath it.
Yep, 6 underneath, good. Sine of 35 over 6. Andrew, what about on the right?
Oh, sorry, I was going ahead. Sine beta over 8.
Sine beta over, what'd you say?
8.
Yeah, very good. All right, so when we cross multiply, I'm going to do that step in my head. You're going to get 8 sine 35 divided by 6. In fact, this one you don't even need cross multiplying. You could just multiply both sides of this equation by 8. And then you'd have sine of beta equals 8 sine 35 over 6. All right, one more step I got to do to get beta by itself. Max, how do I get rid of sine?
The inverse sine.
Yep, I'm going to take the inverse sine of everything on the left and take the inverse sine of everything on the right. Okay, on the left, inverse sine and regular sine cancel. And we get beta equals, and now we have to type that in. Okay, once we type this in, we're going to know right away whether there's at least one solution or no solution. Let's type it in. All right, so we got inverse sine of 8 sine 35. Make sure you close your parenthesis. Divided by 6. Yep, thank you. That should be inverse. So inverse sine of 8 sine 35 over 6. And we get 49.886. Okay, so it's definitely not no solution. We just got an answer, 49.886. So I'm going to write it in the table. All right. What do I do with that answer to find the second answer?
Subtract it from 180.
Yep, subtract it from 180. Good. So 180 minus 49.886. It's 130.114. Let's go back up. Let's look at the angle that was given and see if that's too big or not. Okay, we were given a 35-degree angle to start. Is it possible to fit a 35-degree angle and a 130-degree angle in the same triangle?
Yeah.
Yes. So this time the second answer does work. Any question on what we just went through right there? How we found the second answer, or how we figured out that it does work? All right, so what we're going to do is we're really going to solve two problems, but we're going to use the same table to organize our data. So I'm going to call the first beta, beta 1. I'm going to call the second one beta 2. Okay, the second answer was found by doing 180 minus 49.886. And it was that. Okay, now if there's two answers for beta, what else do you think that means is going to happen here?
Two answers for gamma.
Two answers for gamma, which we'll call gamma 1 and gamma 2. And there's also going to be two answers for C. C1 and C2. So one of your triangles, okay, let me go through which angles are in which triangle. Alpha is in both of them. Okay, the 35-degree angle is shared between the two problems. Alpha, beta 1, and gamma 1. Put them in red. Those are three angles that are all in the same triangle. And then alpha is reused again, beta 2, and gamma 2. Okay? Those are three angles in the other triangle. Okay, let's start by finding gamma 1 and gamma 2. Okay, Ben, how would we get gamma 1?
You would just take, sine of alpha.
Well, keep in mind, to find gamma 1 and gamma 2, we already know 2 out of 3 of the angles in each triangle. So if you know 2 out of 3 angles in a triangle, how do you get the third one?
You just drop the others.
From?
So, 180.
From 180. All right? So to get gamma 1, take 180 minus alpha minus beta 1. So gamma 1 is 95.114. Okay, Sam, what two angles am I going to use to find gamma 2?
Alpha and beta 2.
Yep, alpha and beta 2. So take 180 minus 35 minus 130.114. So we get 14.886. Okay, so now we have gamma 1 and gamma 2. Again, it shouldn't seem like we're doing anything harder. We're just doing the same thing twice. It takes longer. All right, and now we got to get C1 and C2. Let's start with C1. Which angle do you think we're going to use to find C1? Okay, yeah, we're definitely going to use the first row for both C1 and C2. We're going to use A and alpha. Yep, so let's set that up. So sine 35 over 6. And now to find C1, we have to use a certain angle. About page? Which angle are we going to use to find C1? Exactly. We're going to use 95.114. You're going to use gamma 1 to find C1. Sine 95.114 over C1. Okay? So C1 is going to be 6 sine 95.114. Okay, if somebody has that typed in, that'd be helpful, so we could. And then divide by sine 35. Okay. You got 10.429? Okay.
I got 10.419.
10.41? All right,
Yeah,
so that's a little bit different.
It's 10.42.
If you round it, it's
10.429?
420 if you round it.
All right, let me type it in. I'll tell you what I get.
10.1.
Okay, so what you can get depends on if you rounded before you got to the final step. So 6 sine 95.114, and then divide by sine 35. All right, so if you round that, it would be 10.419. That's what I got. Okay. If you got something different, it might be because you rounded earlier. I'm not sure, but let's go with 10.419. Okay, and lastly, we have to finish up with C2. Sean, what angle am I going to use to find C2? that we haven't used yet?
C2 we would use.
You can say the name or the number, either way.
Union.
So one thing you can do is if you look in the table, everything's lined up in the row that you need to use.
We would use the 14.886.
Yep, good. So we're going to use gamma 2, which is 14.886. Okay, so now let's find C2. We're going to start out the same on the left. Sine 35 over 6. And now it's going to be sine of 14.886 divided by C2. All right, so C2 is going to be the product of 6 sine 14.886 divided by sine 35.
2.687.
Okay, what do we got this time?
2.687.
Okay, we'll just go with it. 2.687. Okay, now what we should check, make sure that in each triangle, the biggest side is with the biggest angle. So let's check the ones in red. Biggest angle is 95. The biggest side is 10.86. Yep, C1's the biggest. Smallest angle is 35. And 6, 8, 10, 6 is the smallest side. Okay, let's check the green ones. For the green, beta 2 is the biggest. And out of 6, 8, and 2.687, B is the biggest. Okay, the smallest angle in the green triangle is 14.886. And C2 looks like the smallest side. Good. Everything's good there. Okay, so that's the worst possible problem you can have for law of sines, the two solution case. Any question on that? All right, so we've looked at the one solution, the two solution. Let's try this one. Again, I don't need to draw the diagram to know that this is the possible two solution case. If you set everything up in a table, if you have a row that's blank, it's the possible two solution case. Okay, you got a row that's got nothing in it, and you got a row with everything in it. Okay. So Adam, what do I have to find first here?
Beta.
Yeah, first. No, not beta, sorry. Alpha, yeah. Because of what they've given, we can't use row 2. Okay, so let's set it up. Sine 50 over 1. In this case, because you're just dividing by 1, you don't even need it. Okay, sine 50 over 1 equals sine alpha over 2. Okay, we're going to solve for sine of alpha, so multiply each side by 2 and by 2. So 2 sine 50 equals sine alpha. Now take inverse sine of each side. Okay, and try that on your calculator.
Error.
It says error. Anybody else get an error?
Yeah. Domain error.
Your domain error? All right, let's try it. Inverse sine of 2 sine 50. Okay, if we type it in, we do get a domain error. And that's because of the value of 2 sine 50. Just look at how big 2 sine 50 is. It's 1.53. Okay, when we talk about using an inverse trig function, the argument right there, what two numbers did it have to be between?
0, 1.
Actually, it could be a little bit more than that. Not just 0 to 1, but negative 1 to 1. Okay?
Fair enough.
We tried to type something in that was bigger than 1. So that's the equivalent of trying to type in this function, and that line was about 1.53 or close enough. So there's our sine function. And we're trying to find where the horizontal line at 1.53 hits that graph. Okay, you're asking a question that's not possible to solve. Graphically, that's why. They don't intersect. Okay? That's why you get a domain error. Okay? So there's no solution for alpha. Normally, if we had a solution, we would have subtracted it with gamma from 180. But because we don't have a solution for alpha, what does that mean about beta? There's no solution for that either. And if you can't find the angle, you can't find the side that's across from it. So,
Not a triangle, then?
no, we'll try to sketch this. We'll try to sketch a triangle that has a side 2 units long, 1 unit long, and the angle is 50. And we'll see why it's not a triangle. Okay, to sketch that angle, I'm going to need a protractor to draw it kind of accurately. So let's look at that. Okay, so I've already drawn out a 50-degree angle. Okay, using a protractor. Now I need side A to be twice as long as side C. That's the relationship. Side A is 2 units. Side C is 1 unit. Okay, so let's draw. Okay, A. And I have to keep it at that angle. Can't turn it. If I turn it, I'm going to lose the 50. So I got to keep it just like that. Now, what I'll do to make A twice as long as C is I'll just make a copy of it. Okay, and I'll save that one. I'll need that as well. So now I just created A, and it's twice as long as C. Okay, so there's side A. Let's group that together. All right, side, let's see, C. That side is going to connect up at the top. Okay, that's where side C would be. It would be over here. So what I need to do is I need to turn that a little bit. So the only way I can turn it is if I group it with something else. And then I can erase what I grouped it with. Now I can turn it any way I want. Okay, so there's side C. Now side B, there's no restriction. You can make B any length you want. That's this side. You can make it as long or as short as you want. But you have to keep this as a 50, and you can't change the length of this side or that side. No matter how I try to turn this side is never long enough to reach side B. That's why there's no solution. Okay, it just can't reach. So there's a range of values that it could be, and it could reach, right? And then all of a sudden, we could have the opposite problem if it got too long. Okay, if you had a side that came down like that, that's too long. That's not a triangle either. Right? So there's a couple different reasons why you could get no solution. But that's this one that we just did.
What value would it have to be too long?
To be too long, off the top of my head, I don't know. I'd have to go through and try to solve it and figure that out. That's a much higher level kind of question than what we're going to get into.
Yeah.
If I said, what is the maximum value the side could be before it's too long? That would involve a little bit of thinking to figure out. Okay, but I know that I could at least make it 2 units long, and I know that would work. If I had, then I'd have an isosceles triangle. That side would be 2, and the other side would be 2.
Couldn't you make that side like as long as you want? You just have to keep making the angle bigger in order to meet up with the bottom side.
Oh, you mean making the side bigger?
Yeah, well, that and the other one that
Yeah.
we were talking about, you could make that as long as possible.
Right, I guess that is true. You could just keep, if you're fixing that side, you're saying, you know what, we're keeping it that length, then, okay, there's a limit. But if you're going to allow this side to be any length you want, then yeah, I guess you could make that third side as long as you want, assuming you're allowing the other side to change continuously. But I think Andrew's question was, assuming we leave that side alone, what's the maximum length that you could have? Any other questions on that one? Why there's no solution? Okay, I'm not going to have you make a sketch, but I think that shows it pretty clearly. All right, so let's look at two word problems. Okay, so the first one says it's about a surveyor. So what they're going to do is try to measure the height of a mountain. Okay, and to do it, they're going to take two separate sightings. Okay, a sighting is basically, if you've ever seen on like the side of the road, those people that set up like a tripod and they're looking through it, and sometimes down the road there's another tripod. Has anybody ever seen what I'm talking about?
Yeah.
Okay, they're taking sightings and they could be measuring property boundaries, all kinds of things.
They get paid good money too.
Just for surveyors?
Yeah.
Yeah. So this guy's going to survey a mountain from two different locations, and he's going to do it over a distance of 900 meters. Whether you're using feet or meters, the units don't matter for this particular problem. It's more about the diagram we set up. All right, so he'll stand at one spot. He's going to take a sighting, meaning he's going to measure his angle to the top of the mountain using a transit. Then he's going to back up 900 meters or drive 900 meters back, and then he's going to measure the angle again. Okay, from his first observation, he got an angle of 47 degrees. Okay, an angle of elevation is the angle off the horizon. So if you're on the, you're on the ground and you're looking up at something, the angle that you have to look up at, that's the angle of elevation. And then as he backs up a little bit, the angle would get smaller. Right? And the way you could kind of make sense of that, imagine you're looking up at the light. Okay, if you're really close to the light, you're almost looking straight up at it. But then as you start to back up more and more from the light, you don't have to look as steep at it. So his angle decreases a little bit. Okay, one thing we're going to assume here is that the transit is on the ground, level with the ground. All right. Normally a transit isn't. A transit is on a tripod and it's maybe like 4 or 5 feet above the ground. But since we're measuring the height of a mountain, for our purposes, if we're off by 4 feet, that's okay. All right, so the big thing we have to do is figure out a diagram. Okay, what's something that's very important to put in this diagram to start to make a sketch of it?
Triangle.
Okay, we're gonna create a triangle by the things that we put in the diagram. What's one thing that's going to be part of this triangle when I sketch the diagram? Think about if you were actually drawing a picture of somebody doing this. What's one real important thing you'd have to have in that picture? The what?
Line.
A line that represents what?
Line.
Sure, so we need a mountain. And the mountain has to be on the ground somewhere, right? So we need ground. We'll assume level ground. Okay, so let's put the ground in. Okay, here's our ground. Okay, and we're also going to have a mountain. Okay, for the purpose of what we're doing, you don't actually have to draw something detailed. You can just draw an object that's up off the ground. Okay, there's the height of our mountain. Whatever. All right, so we've got the mountain. And now we need the surveyor. Okay, he's at 2 different spots. Okay, the first spot, let's have him right here. And the second time, he's over here. Now we know the distance between those 2 sightings. How far apart are the sightings? 900 meters. Okay? And when he takes the sighting, he's taking a sighting to the top of the mountain. So he's going to do a sighting there and another one there. Okay. From his first sighting, okay, he had an angle of elevation of 47 degrees. Okay, so that's right there. That's the angle that he had to look up to see the mountain. Okay, how about the second time? What did he have to look up? What was the angle?
35 degrees.
35. Okay, that's my second angle. So now I basically have a triangle right here. Okay, so instead of looking at it as a word problem, let's just look at this triangle now and solve it. This side's 900. This angle is 35. Problem is I need another angle in the triangle. How can I get another angle inside based on what they gave me? Yeah?
The 47 and the angle next to it are like complementary or something, so they add up to 180.
Supplementary, so they add up to 180. Yeah, very good. So these angles have to add up to 180. So just do 180 minus, 180 minus 47. We get 133. Now we've taken this from being a word problem to just be a problem about a triangle. It's angle, side, angle. This is not the case where you have to check for two answers. All right? So what we're going to do, let's see, to measure the height of a mountain. Okay. So what we're going to have to do first, it actually has two steps. We need to know that side. Okay, let's find that side first. And I'm just going to label it X. Also, I'm going to need this angle up at the top. But since I have 2 out of 3 angles, I can just add them up and subtract from 180. So minus the 35. So the angle up at the top is 12. And the reason I needed it is to set up the law of sines. Sine of an angle divided by what's across from it equals sine of an angle. So I'll do sine 35 divide by what's across from it. Okay, so let's find x. Now x isn't the height of the mountain, but it is something that you do need to find the height. And after we have x, the problem becomes much easier, and we don't need to use any more law of sines. Okay, so we're done with law of sines once we solve this. So it's 900 sine 35 divided by sine 12. Let's see what we got. Okay, so we got 900, say sine 35 divided by sine 12. Okay, so we get 107 point.
Missed the division symbol.
Oh, thank you. Yeah, that looked a little small. All right, 2,482. Since we're measuring the height of the mountain, we don't have to go to 3 decimals. Let's just go to 1, 0.9. So 2,482.9. Any question why that's not the height of the mountain, though? That's that side. All right. Now we're going to make one more triangle. Okay, but we're going to use part of that. 2,482 is going to be one of the sides. Draw a line straight down. Okay. All right, so now I've drawn that line straight down. What kind of triangle did I just create?
Right triangle.
Yep, I just created a right triangle. All right, so we just created a right triangle. All right, so in this right triangle, Okay, let's look at this part right here. Okay, triangle and green. That 2,482, what side is that in that green triangle?
Hypotenuse.
It's the hypotenuse of it. Okay? And now that we have a right triangle, it's going to be a lot easier to solve. The hypotenuse is 2,482.9. That's a right angle. And the bottom side is 47. And let's call the height y. Let's look at the names of the two sides that we know in relation to that 47-degree angle. Okay, what's side y? Is that opposite, adjacent, or hypotenuse?
Opposite.
Opposite. And then 2,482.9, you guys just said was hypotenuse. Which trig function has opposite and hypotenuse in it?
Sine.
Sine. Okay, so we'll set up our problem and solve for y. By the way, you don't have to use y. I just picked y because it was a vertical measurement. All right, so sine of my angle equals opposite over hypotenuse. And the hypotenuse is 2,482.9. Okay, last step to get the height of the mountain, times by what?
Well, the 2,482.9.
Yeah. So multiply each side by 2,482.9. And that will give me the height of my mountain. Okay, so this was kind of a problem that combined a little bit about what we learned this week, using law of sines. That was the first step. And then we turned it into a right triangle problem in the second step. So find sine 47 times 2,482.9. Okay, so the height of the mountain is, we'll go to the nearest meter, 1,816 meters. Which is pretty decent mountain. Okay, any question on how we did that one? All right, so we'll finish up with the Coast Guard problem. Okay, and then after that, I think we should have a few minutes. I'll start the homework. Okay, so we're going to start off with 2 Coast Guard stations. I don't think in this problem we're going to need to use right triangle trig. We're going to be able to just stick with law of sines. Okay, and the 2 Coast Guard stations are Zulu and X-ray. Okay, and their relative position to each other. Zulu is 120 miles west of X-ray. So in this problem, I don't think I'm going to plan on using A, B, and C to label anything. Probably going to use Z for Zulu and X for X-ray. Okay, so a ship is going to send out an SOS. And again, let's pretend that the ship has no way, it's cloudy, so they can't look at stars to navigate. Their GPS isn't working, but their radio still works. So all they can do is send out a broadcast, and it's nighttime, so they can't see anything. Okay, but there's 2 stations, both receive the signal. If only one station received the signal, that'd be a problem. Okay, to triangulate someone's position, 2 people have to be able to hear your message at the same time, just like with a cell phone. To triangulate where you are with a cell phone, you have to be in range of at least 2 towers, or more. More is better. But if you're in range of at least 2 cell phone towers, they can find out where you are to a certain degree. We'll have to talk a little bit about what the direction is here. So it says that the call to station Zulu indicates the bearing to the boat is 40 degrees east of north. Okay, so I'll draw that out and I'll explain what that bearing means. Bearing is 40 degrees east of north. It's pretty much what it sounds like, but we'll make a sketch. Okay, now X-ray gets the same message. Okay, X-ray though gets a different bearing because they're 120 miles away from the other station. Okay, so their bearing for the boat is 30 degrees west of north. So when we sketch it, you're going to see that the boat is between the two Coast Guard stations. Not necessarily exactly centered, but it's somewhere between the two out in the ocean. Okay, and what we want to find out is how far each station is from the ship. So again, on a test, that would all be written for you. It's kind of a lot to copy, but it would all be on the test. All right, so let's try to make a diagram. Okay, first thing I'm going to do is draw what I'm going to consider the coastline. Okay, and I'm going to make it a straight coastline, and I'll put the two Coast Guard stations right on it. Okay, so we've got Zulu and X-ray, and they're 120 miles apart. So here's our coast. I have to go back and remember which one was to the west of, so it says Zulu is west. So this would be Zulu, X-ray, 120 miles between the two. Okay, the boat, somewhere out there. Okay, again, it's not necessarily to scale. Now we're going to look at the two bearings of the radio signal that came in. So the first one, okay, from Zulu, they can tell that the boat is somewhere on a bearing 40 degrees east of north. Okay? So let me draw a kind of a compass so you can see that. Okay. North and south would be a line that goes straight up and down. East means to the right. Okay, so if you're 40 degrees east of north, it'd be something kind of like this. And that would be 40 degrees. 40 degrees to the east of a line that's directly north. Okay, that's the idea. The problem with only one station hearing it is this Coast Guard station knows that the boat is somewhere on that line, but they would have no idea of knowing where on the line. This is where the second station comes in. Okay, so the second station says that they received a radio signal on a bearing 30 degrees west of north, okay, from their position. Okay, so again, let's draw our compass. That line is just there to represent north. Okay, and that station can pick up the signal, and what did we say, 30 degrees? West of north. Okay, west means to the left. 30 degrees west of a line that's directly north. And now they know that they're somewhere on that line. But now that the two stations work together, okay, they can figure out basically where those two dotted lines intersect, and that would be the relative position of the boat. All right, so let's kind of take that and just make it into a triangle. Okay, so here's our triangle. Okay, how long is the bottom side in the triangle? Yep, 120. How about this angle?
50,
Yeah, how do you know it's 50?
because that angle plus the 40-degree angle is complementary.
Right,
90 degrees from north to the coastline.
perfect. And you can use the same reasoning on the other side to get an angle of 60. And now how far is each Coast Guard station from the boat? This is the boat. This is one station. That's the other station. So all we need to do is find the lengths of the two sides, and that's it. We are going to need the third angle, though. Without that third angle, we don't have a complete row in our table. So what would the third angle be? That's a 50 and a 60?
70.
70? Okay, how'd you get that?
Subtracted 110 from 180.
Yep, so you add the 50 and 60, you get 110. Minus it from 180, you get 70. Good. Okay, and let's do our setup to find, we could call this side A. We'll call that side B. Let's set up our proportion. Okay, what can I put on one side of the proportion? Sine of?
Sine 50 over B.
Sure, that's good, sine 50 over B. Equals, what would go on the other side?
Sine 70 over 120.
Sine 70 over 120. So once you take the word problem part out of it, you just reduce it down to a diagram, then the mathematics, kind of just chugging through the arithmetic and the cross multiplying, that's easy. You just got to get a diagram that is accurate. Right, so in this case, B is 120 times sine 50 over sine 70. Let's find out how far that one is. So 120 sine 50. Okay, so the first Coast Guard station is, I think we did this in miles, so it's roughly 97.8 miles away. And that, I believe, was the left side, or, oh, that was B, sorry, so that's the distance from X-ray.
No, that's the distance from Z. Or, yeah.
X-ray, right? Yeah. So we just found side B, so that's X-ray to the boat.
Oh, okay.
Yep. So we did that. That's good. So X-ray to boat. Okay. And now let's set up the same thing one more time. We're still going to use sine 70 over 120. Because both of those we know. Equals, okay, this time what am I going to use for my angle? Yep, sine 60 over A. Very good. And in terms of the work to solve it, it's exactly the same as the first part. Cross multiply. So, 120 sine 60 over sine 70. It's not really hard, but it is time consuming. It takes a while to draw these pictures and find all this stuff. Which is why on a test you wouldn't have more than one word problem. And even for other types of problems, probably only 5 or 6 problems at most. Each problem has 3 parts though. So, all right, so in fact, if you have the last thing you already typed in, all you have to do is change one number. Okay, 120 sine 60 divided by sine 70. So that's 110.6 miles. That's from Zulu to the boat. So if they were going to try to send out a rescue to that boat, what station would it be better to send it from? X-ray? Why? Because it's closer? Anything else you'd have to think about more for like a real life problem?
Currents and winds.
The what?
Currents and winds.
Yeah, the current. Let's say the boat is drifting towards Zulu. Let's say the boat, well, actually the way I drew it, it is, but let's say the current is pushing it at like 30 or 40 miles an hour towards Zulu. Maybe by the time Zulu gets there, right, it'd be quicker for them. The tricky thing about the boat drifting is The pilot, if they're taking a helicopter out to get that boat, the pilot would have to fly to where the boat is going to be in, say, if it takes them, I don't know, an hour to get there. So the pilot would be flying towards a spot where the boat's not even at yet, and the boat eventually would get there by the time he gets there. So that's a little tricky. All right. The other thing you might have to take into account is the specific kinds of equipment each Coast Guard station has. Right? Maybe Coast Guard Station B only has cutters like a boat, and A's got a helicopter. Well, the helicopter can probably get there faster. So even though it's farther, maybe they're the right ones to go. Okay. So there's a lot of other factors. We've really simplified the problem, but all I care about is the mathematics behind it. Okay. Any questions on that? All right, so I think that's good. We'll stop there for today. Okay, so for tonight, on page 267, I have you do 29 to 35, just the odds, and 39 and 43. If you get stuck on the word problem or you have trouble, that's okay. We'll go over it tomorrow, and we'll finish with law of cosines tomorrow as well.